Hey, my name is Marty Gubar, and I'm from the Autonomous Database Product Management team, and I have a fun demo for you today. So we're going to see how Oracle MovieStream, which is a fictitious movie streaming company, is able to deliver intelligent applications on Oracle Cloud Infrastructure, and these applications are powered by Autonomous Database. So the demonstration is going to highlight a few key things. First, how you can simplify your data architecture by eliminating data silos. Second, by eliminating those silos, you can now more easily infuse intelligence into your applications. And when creating those applications, developers shouldn't have to make compromises, right? You should use a data platform that offers a rich set of APIs that best match the application development needs. And then finally, you can't forget those non-functional requirements: security, availability, scalability. These are all critical. And you can allow an autonomous data platform to solve those issues for you. So let's dive into the demo. Let's first set some context. MovieStream has many of the same challenges as other companies. They need to delight their customers and provide them with the right products at the right time, because frankly, competitors are just a mouse click away. Now, to achieve that goal, they've infused their application with a ton of smarts. Machine learning and spatial has been used to predict customer churn and then make a localized offer to keep those customers happy. Now, Analytics SQL is used to find out what's hot on MovieStream right now. And then that Analytics SQL is combined with spatial to rank movies that are hot in my location, so near me. Next, JSON Analytics was required to query complex fields, right? In this case, Academy Award-winning films. And then finally, we used sophisticated graph algorithms to provide individualized recommendations based on viewing patterns. MovieStream was developed using an open source JavaScript framework known as Vue.js. And it's connecting to the Autonomous Database document store through a SOTA REST API. And it could just as easily have been done using the Mongo API. Now, the data for this application was originally sourced from Wikipedia, so thank you, Wikipedia. And I also really want to acknowledge and thank the team from MAD, including Luke and Jeff and Cassie, who did a phenomenal job designing this application. Okay, so I go into MovieStream, and we have different customers. Emilio, Blanca, Esther. You can see Emilio's been a customer for 3 years. Blanca also for 3 years. She's from LA, Esther. And when I go to Emilio, I jump in and I'm seeing movies, a personalized view of the site, right? So we see, hey, this is what's popular on MovieStream. So going across, the entire all users, this is what people are watching. I can look at what's going on just in my area, what's popular there, award winners. And it looks as though these genres that you see here, this is based on Emilio's viewing experience. This is what he seems to enjoy: dramas, horrors, comedies, thrillers, and family movies. So I can, just go down and see these are the movies that were recommended to him: Digging to China, Tumbleweeds, etc. Now, applications just want simple APIs. You pass in a key, and you get back a value. In this case, I pass in a customer ID, and I get this landing page. Everything that's required to paint the page. And returning this in JSON format is really useful because that's easily consumable by the application. Now we have a couple of ways of doing that. The first one that we're going to look at is Mongo, and this is new. We have a Mongo API on top of ADB. What this means is that applications that you may have developed using Mongo today should be easy to migrate to Autonomous Database because we now support the Mongo API. So literally right now, we are using an application called Compass. And Compass is, you could think about it as being their SQL developer, right? This is their utility for, creating collections, editing collections, etc. So you can see here that I have a MovieStream database. And within that database, we have numerous collections, a customer collection, the landing page, etc. Now, if I go into landing pages, and I can now see this is basically the key lookup where I passed in a customer ID. And when I passed in that customer ID, what do I see? Well, the array of genres, right, that were used here to paint the page, as well as each of the shelves. So we have a shelf that was popular on MovieStream, popular in your area, award winners. And when you drill down, you can then see each of the movies, like One Flew Over the Cuckoo's Nest. This is, again, a very simple API into Autonomous Database using just a key value lookup. And it has some very basic filtering capabilities as well, right? So let's say we go to the movie collection and we look at the movie collection, and instead of seeing all movies, maybe I would like to see those with the title Rain Man. Okay, so you basically specify the title, an attribute that you want to do a lookup on. In this case, I'm saying Rain Man. And Rain Man is a 1998 road drama film directed by Barry Levinson. It's won numerous awards. Has all these different cast members. So these are my different collections. So not only can I read these collections, I can also create new ones or edit these collections. So maybe we'll create a new collection called My Dogs. And when I create My Dogs, I have this new collection. And I can go in and just start adding data to this. So what I'm actually doing is I'm updating an Autonomous Database JSON collection, right? So we have My Dogs. His name is Pula. And Pula is her breed is, who knows? She's just a mutt. Right? And I've inserted this document. Well, I can now add another document. And the nice thing about document stores, and this is why they're so popular, is that there's no schema associated with them. So I could say, my other dog, I forgot my attribute, name, is Coda. And her, we didn't say anything about age before, but her age is 3, right? I'm just simply inserting documents, and now I can just do lookups based on those documents and those attributes. This is the Mongo API. Another option we have is we can use a REST endpoint called Soda. In this case, similar to using Mongo, here I'm going to say, hey, I want to get the landing page for a specific customer. Right, so you make a REST request, that's a query. And in this case, I want to get the landing page for this customer ID, Emilio, right? And here you can see, again, what's popular on MovieStream and all of the movies that are recommended to him. Very, very simple. key value lookups against the JSON collection. Okay, so we saw how a document store simplifies application development. The challenge with document stores, they don't provide an analytic API. REST and Mongo APIs, they provide basic filtering over complex objects, and then they return that result in a format that's easily consumable by applications. So let's look at how we can now analyze data across both the document store and the transaction store using Oracle SQL. And we'll do that we'll see a behind the scenes look in SQL Developer, and then follow that up by looking at dashboards in Analytics Cloud. In the Oracle database, the collection is simply exposed as a table. So now when you want to do queries of, I'm going to grab the title or the movie ID from the collection, not a problem. If I want to then say, hey, give me all the movies that star Robert De Niro, well, we'll just query the cast. And now we're looking at those movies that have starred Robert De Niro. Do our customers like that? Well, let's combine sales data, a transaction table, with that document store. And now we can see, how do our customers like Robert De Niro movies? Well, this is great. I'm using SQL Developer, but I would really like to use another tool like Analytics Cloud. So to simplify this for my Analytics Cloud users, I'll just create a view. And that view is going to pull out some of those key attributes from movie and combine it with data from sales and the genre data. Okay, so let's jump into Analytics Cloud. And in Analytics Cloud, we've imported that view definition, MovieStream sales. And Analytics Cloud has now profiled the data, and you can see sales data, views, the devices that people have used, etc. Well, let's create a workbook from this data set. Okay, now I'm going to drag those two columns to my page, and we can see my daily sales or my daily views. But let's filter this. I'm going to take day name, and let's look at the beginning of 2020. April 1st. And here you can see the trend line. And what you'll notice is that it turns out there's spikes on the weekend and then things drop off during the week. Well, and you can see that that's pretty consistent. Let's look at movies that have won the Academy Award. So again, this is coming from a complex data type in the database. And I'm going to add those movies that have won the Academy Award. Interestingly, one of the things that you'll find is that February 10th, a huge spike. It turns out that February 9th was the Academy Awards. And we see that there's a huge spike to Academy Award winning movies just after that date, more so than other movies. So it's kind of a pretty interesting discovery that we've just quickly made. We want to make sure that we're providing the right products to our customers. To do that, we're using Autonomous Database's graph analytics to generate movie recommendations. And we'll go through how we developed this analysis using Graph Studio. And we'll use what's called the personalized salsa algorithm to create those targeted recommendations. We've already created a graph using Graph Studio, and now we're going to query that graph, and it's called Movie Recommendations. Graph provides its own query language called PGQL. Okay, and PGQL is a specialized graph language. So here we're looking at an edge, or a vertex called Emilio, and Emilio has purchased several movies. Okay, so that's the relationship that we've created. Next, we can see, well, let's look at the combination of people, right? So graph is all about relationships, right? How one node, one vertex relates to another. So here we can see the movies that both Emilio and Floyd have both purchased. Now, as we go through this, using this type of methodology, we're going to apply a graph algorithm. That graph algorithm is called a personalized salsa algorithm. So we're going to create recommendations using the relationships, the strength of the relationships between these, the members of that graph, the vertices within the graph. We've just run that algorithm to produce the recommendations, and we can view them. And here we can see now the movies that have been recommended to Emilio. Well, let's save those recommendations now into the database. So literally with a single, we're using Python's API. We have a Python API to the graph engine to analyze the individuals, their behavior, used a personalized salsa algorithm to understand the relationships and make the recommendations of movies based on what other people have viewed. The last leg of our demo here is to predict churn and then identify who we should actually promote to. So we're now in Autonomous Databases, machine learning, and I'm going to use AutoML to create a new model. We'll call this churn prediction. And as a data source, we're going to use a churn data set that we've had. And we are going to target the isChurner column and for that cust ID. That would be the case. Okay. In addition, we'll specify a few other things. We'll specify the top models. We'll do 2. We'll use balanced accuracy. And now let's start. And we're going to use AutoML to evaluate different models and use them to make our predictions. Now that the model creation is complete, you can see that age, average discount, and gender, these are the attributes that have the greatest impact across models as to whether or not somebody is going to churn. It looks as though the decision tree turns out to be the best model with the best accuracy. And here you can see for the decision tree that age, gender, whether or not they watch thriller movies, these are high predictors, again, for this type of model as to who's going to churn. And in terms of a confusion matrix, there's about a 95% accuracy in terms for this model, with false positives at around a little less than 4%. So this is a pretty good model. What we're going to do is we're going to rename it ChurnPred. And now we're going to score our customers using this model. Let's go to the machine learning notebooks. Okay, so now let's score our customers in our machine learning notebook. And we have a couple of ways of doing this. We can use the Python libraries that are available with our machine learning feature of Autonomous Database. And here we've just scored the customers using Python. We can also not just predict the churn for each of our customers through the Python libraries, but you can even do it with a simple SQL statement, right? So here we are using our SQL capabilities enhanced with machine learning, being able to score machine learning models. And we've now created a table that contains, it's called latest potential churners, those who lists our customers and their probability of churning. Now, their probability of churning is interesting, but we also want to focus on those customers that are high value, right? And not only that, we're going to have a promotion. And that promotion is to offer them some free pizza. So we're gonna look at, are they a potential churner? Are they a high value customer? And how close are they to one of our participating pizza places? And we're using our spatial capabilities to figure out how close they are to various participating pizza locations. So here, although, Gilbert Lee is a highly rated customer, he's 160 kilometers away from the local pizza place. So we're going to focus on Emilio Welsh. And now that we're focusing on Emilio, we're going to actually add that promotion to the list of promotions. We're going to publish this promotion just out generally. So both to the email campaign as well as their landing page is going to be updated. Okay, so now let's go back to our application. And we're logged in as Emilio. And what we're going to do now is just simply refresh the page. And in refreshing the page, you're going to see a couple of things. One, you're going to see, hey, Emilio now has a notification. This notification is for that specialized pizza offer. This is the pizza place that's nearby. We also have re-executed the algorithms for his recommendations through Graph. And we now see totally different movies that are now being recommended to him based on that salsa algorithm. So again, that profile has been updated, that cache has been updated, and the application now automatically can take advantage of those analytics that have taken place in the database. I hope you've seen the power of Autonomous Database and how it can dramatically simplify your data architecture. Now, when you're building your applications, keep in mind not only the APIs you'd like to use for a single task, but also how you will need to use that data for analytics. Microservices with special purpose data stores can present some real challenges in the long run, dramatically increasing costs and complexity when you're asked to do comprehensive analytics. And of course, don't forget about the non-functional requirements like high availability, security, and more. So get started. Take Autonomous Database for a spin and do it for free. We have lots of hands-on tutorials to help you get started. Building apps using REST, data loading, machine learning, spatial, graph, managing the platform, and so much more. There's probably 50 workshops that you can run, and it's free. So go to bit.ly/getstartedwithadb, and those workshops will all be at your fingertips. Thank you so much, and have a great day.